Here's the main idea for Bayesian statistics. So you have data, which I call D, and some theory that I call T. Bayes' theorem says the probability of getting the data given the theory times the probability of the theory being correct is equal to the probability of the theory being correct given the data times the probability of the data. Breaking it down, the probability of getting the data given the theory, that's what they usually calculate in probability class. Normal distributions, binomial, etc. We know how to do that. The probability of the theory being right, well, you need to put something in, an assumption, your prior beliefs about what's likely to be the true value of the mean, etc. Now, ordinary statistics usually just assumes, I have no idea. And what that generally means is assuming a uniform distribution. But Bayes makes that explicit and says, all right, exactly what do we think is likely to be true here? And you use that as your prior belief. The probability of the theory being right, given the data that we got, that's what we actually want to know. And the last piece is, what's the probability of getting this data? In like all the universe and everything you can imagine and beyond, we have no way of knowing that. So that's why it looks so impossible to do. But there's a trick. Now, the probability of theory 1 being right, in other words, say the mean is 5, given the data, is by Bayes' theorem, probability of data given theory 1 times probability of theory 1, which we assumed, over the probability of the data, which we have no clue. Likewise, for mu is 7, say. If we divide them, we get the relative probability, theory 1 being true versus theory 2 being true, the mu being 4 versus the mu being 7. And the thing we have no clue about cancels. And so these become things we can calculate from probability, and these are things we assume, and we're in business.